Today's problem is another one submitted by a viewer, and it says, let gamma denote a curve, y is equal to y of x, which is in the first quadrant, and let the point 1, 0 lie on it. Let the tangent to gamma at a point P intersect the y-axis at y sub p. If P to yp has length 1 for each point P on gamma, then which of the following options is or are correct? And you're given a bunch of relations between, basically a bunch of possible functions for y or differential equations that y can satisfy here. Okay, so let me make sense of the statement that we're given here, or the description of this curve. So we have some curve in the quadrant. So the point 1, 0 is on this curve. The curve is specified to be a function of x, so it doesn't loop back on itself. I'm going to assume at least it's not like a multi-valued function. So, if we have a curve in some arbitrary way, we take a point P, we take the tangent line to that curve, it intersects at the y-axis at yp, and we're told that this length is equal to 1 for every point on gamma. Okay, so I suppose for a couple of these, for two of the options where y is just given as a function of x, we could just directly check. Let me first make sure that for each of these points that 1, 0 is on it. Okay, so for option A, y is equal to log of 1 plus 1 minus root 1 minus x squared over x minus 1 minus x squared under root. Okay, so when x is equal to 1, that's gone, so that's 0, and that's 0. Yeah, okay, so that works. And for option C, we just have the negative of what's written here. And so naturally, this point is also on the curve. Well, then it's in the first quadrant. And option A and C are negatives of each other. So they can't both lie in the first quadrant. Okay, so we certainly need x to be less than 1. If I just substitute x in the first option, what if I just substitute x is equal to a half? Or another way of writing this, because x is between 0 and 1, this will be positive. How does this compare to log x? Like, I suspect that this here, this is probably negative, right? This whole thing. Well, let me come back to those two options. But A and C can't both be true because one of them does not lie in the first quadrant. And in fact, if I look at options B and D, so one option is, option B is x, y prime plus root 1 minus x is equal to 0. The other is x, y prime minus 1 minus root x is equal to 0. If I look at my plane, call that the point 1, 0, this curve has the same derivative as that curve except multiplied by -1. So, if one curve goes like that, the other goes like that, right? Unless they can have like fundamentally different solutions. Right? Like the derivative has to be negative here. It has to be decreasing into this point 1, 0. So that can't possibly be true, right? Because this will always be positive. Okay. So now the question is, do I want to directly check I think what I'm going to do is take all the information that's given. We have a point on the curve, and we're talking about a tangent point to that curve. So that's going to give rise to a derivative somewhere. If I have a point on the curve and its slope of a tangent, I can find the point where it intersects and just force that to be equal to 1 and see if I come up with a differential equation. Okay, so just going to suppose that I have some, there's my point P. Okay, so let's say P is equal to the point x, y of x. Then Py is equal to 0, and I'll have the y coordinate will be y prime times x, right? Y prime evaluated at x times x. Plus y of x. Right? I take this y value, so that's y. It's multiplied by negative x, right? There, okay. So let's compute the distance between these 2 points. D squared is equal to x squared plus x squared y prime squared, and this is always equal to 1. I mean, this is not the same differential equation in either options B or D. What if, but maybe we can change it around. So y prime squared plus 1 is equal to 1 over x squared. Okay, so now it's the same as one of these two, B or D. So I already ruled one of them out, right? Yeah, so option B could be correct. So then the question is, out of options A and C, do one of these satisfy this differential equation? I probably just have to take a derivative of this, right, and see if that works. So let's look at option A. Y is equal to log 1 plus root 1 minus x squared. I'll write this as minus log x minus 1 minus root x squared. Take a derivative. Might be pretty messy, but all right. Is this the best way to go about this one? I mean, like this doesn't look like it's going to satisfy this ODE, but I hope I didn't make like an algebra mistake in all this. I'm actually going to verify this. I'm going to go through the computations again because I'm worried I've made an algebra mistake. I think I did make an algebra mistake, right? I forgot this term, but I'm going to continue from my new steps here. All right, seems I've finally shown that this does in fact solve, one of these functions does solve one of these ODEs. So I'm pretty sure then the answer to this one is both A and B. So let me kind of recap everything I ended up doing here. I wrote down, the relationship between P and Py in terms of y prime and all that. Ended up doing some rearrangements, and I ended up with this. But I argued that of the two ODEs that were given, only one of them can be a solution because we have to approach this point from above. The point 10 has to be approached from above, so the derivative has to be negative when x is equal to 1. And so of these two ODEs that we derive, we have to take the negative sign here to ensure that y prime is negative. Then what I did is I showed that the curve defined by option A satisfies that ODE. I just brute forced it. Took a derivative of this. It was really just a bunch of messy algebra. I probably should have used a placeholder for the square root term much earlier. I didn't do that till pretty much right at the end. And then I ended up with the same ODE that that we had derived in the first place. So unless I made some algebra mistakes or something like that, I'm pretty confident with the approach that I took here, and I think that the answers are A and B. To be clear, all of these curves satisfy the property that the distance from a point to its tangent intersect is equal to 1. It's just that some of the options are not in the first quadrant. Yeah, that's pretty much it. If I have any more to say, I'll put it down in the description. Thanks for watching.